In this video, you will learn how the water treatment method gravity-driven membrane, or GDM filtration, works and in what contexts its use is recommended. You will also learn about its advantages and disadvantages, and you will get insights into different applications of the GDM technology. Kennedy Wenyama and Henry Uma, who are the WASH experts based in Uganda, are guiding you through this series of videos. They have already been involved in the construction and maintenance of various GDM treatment systems.
Groundwater is such an important source of drinking water. However, in some places, groundwater is salty, contaminated, or simply not available. An alternative source of surface water has to be introduced in this situation, even though it possesses a higher risk of contamination with pathogens. Also, surface water has got a risk of high turbidity. And turbidity possesses quite a number of challenges for different technologies of water treatment. A very robust technology suitable for treatment of surface water is gravity-driven membrane filtration system.
A GDM system contains 4 elements: a pump house with solar panels, a membrane tank, a clean water tank, and a water kiosk. Membrane ultrafiltration modules are at the heart of the GDM technology. They are able to remove turbidity and pathogens like protozoa, pathogenic bacteria, and the majority of viruses. Basically, anything larger than 40 nanometers is removed, as the pore size of ultrafiltration membranes is 20 to 40 nanometers. As the name suggests, the filtration process is driven by gravity, so no pump is needed.
These filters need very little maintenance, such as backflashing, because low pressure in the system and biological activity in the biofilm that grows on the membrane keeps the biofilm porous. Therefore, the membranes do not clog and only need to be flushed once a month for a stable flux.
GDM is one of the few technologies that is capable of removing high turbidity and microbiological pathogens in one step. Therefore, GDM is specifically suitable for surface water like lakes and rivers. GDM also is capable of treating microbiologically contaminated rainwater, spring water, and groundwater.
As with every technology, GDM has advantages and limitations. GDM removes bacteria, viruses, and protozoa. GDM can treat water with high turbidity. No electricity is needed. No regular backwashing or chemical cleaning of the membranes is required. Only very minor operations and maintenance work are required. GDM cannot filter chemical contaminants of natural or human origin from agriculture, industry, or mining. The membrane modules need to be imported and cannot be locally produced. A GDM system needs trained mechanics and technicians to carry out maintenance work. The initial investment costs are substantial.
GDM filters can be assembled in vertical or horizontal configurations and in different sizes. There are filters for household applications as well as for community scale treatment sites.
This video has introduced you to the GDM technology. You have learned that the gravity pressure of water drives the filtration process of a GDM system. You have seen that a pump is not required for the treatment process, but may be necessary to transport water from the source to the treatment site. The main advantage of the GDM system is that even if it treats highly turbid surface water, the membranes do not get clogged. In addition, the system needs little effort for operation and maintenance. The main disadvantage of GDM is that the membranes need to be imported.